Hello, welcome to Forest Learn. This video is about the basics of forces. You'll have studied forces previously and will probably have some familiarity with what we'll discuss in this video. However, it's often the case that the basics of forces, despite being relatively simple, are often poorly understood, which can lead to problems down the line, given that force is such a key concept in physics. If you're wondering why there's a picture of a gecko here, to find out, stick around until the end of the video. Simply put, a force is an interaction between two bodies or a body and its environment. The word body is just another word for object. Body doesn't necessarily mean a human or a living body. Here are a few examples of forces and interactions between bodies. In this first example, a person is pushing a box to the right, and therefore applying a force on the box to the right. The force is shown by this arrow or vector here. In this example, the two bodies that are interacting are the person and the box. Now if the person manages to get the box moving and sliding along the ground, eventually the box will come to a rest due to the presence of this force acting to the left on the box. This force is known as friction and exists due to the contact between the box and the ground. We can say that the box interacts with a part of its environment, namely the ground. In our third example, a ball falls towards the ground and experiences a downwards force known as the weight of the ball. In this example, the ball interacts with the earth. In other words, the two bodies that are interacting here are the ball and the earth. In our fourth and final example, we have two electrons drawn here as these filled white circles. And you can see we've drawn a force on the electron on the right here. It experiences a force to the right. Remember that electrons carry negative charge, and therefore these electrons will repel one another because like charges repel. So the force drawn here to the right, this is a repulsive force that acts on the electron here. So we can say that in this example, the two bodies are the two electrons and they're interacting with each other. For each of the four forces that we've seen in the preceding examples, the force acts on a body and is exerted by another body. In example 1, the force acts on the box and is exerted by the person. In example 2, the force again acts on the box, but this time is exerted by the ground. In the third example, the force acts on the ball and is exerted by the earth. And in the final example, the force acts on the right electron and is exerted by the left electron. While these examples may seem fairly straightforward, there are more complicated scenarios where it's vital to know for each force what body the force acts on and which body is exerting the force. If you don't know this, you may be thinking of a force that doesn't actually exist. Forces can be classified as contact or non-contact. As the names suggest, contact forces are present when the two bodies make contact or touch each other, whereas non-contact forces naturally are when the bodies don't touch each other. So for example, in our first two examples, the forces were contact forces because the bodies made contact with each other, whereas in examples 3 and 4, because the bodies weren't touching one another, those forces are examples of non-contact forces. Every force is a specific type of force. So in example 1, the force on the box is what's known as an applied force. That's basically the name we give to forces due to people pushing or pulling on objects. In the second example, the force on the box due to the ground is what's known as friction, which you're probably familiar with. In the third example, the force on the ball acting down is the force of gravity, and the name we give to this force, as you're probably aware, is what's known as the weight of the ball. In the final example, the repulsive force on the two electrons is what's known as the electrostatic force. These different types of forces aren't just a matter of names. Different types of forces have different properties or characteristics. For example, the force of gravity and the electrostatic force share some similarities, but also important differences. There are many other types of forces. Here we've just listed a few others that you may be aware of. Regardless of the situation you're looking at, you must be able to say what type of force or forces you're dealing with in the problem. Let's summarize everything we've discussed so far. A force is an interaction between two bodies or a body and its environment. Every force acts on a body and is exerted by another body. Every force is either a contact force or a non-contact force. And every force is a specific type of force. We've discussed a number of different types of forces and mentioned that there are many others. Just how many different types of forces are there? It turns out that so far, physicists have discovered just 4 fundamental forces, or interactions. In other words, all the forces we discussed and listed are, if we examine them closely, just examples of these 4 fundamental interactions. Out of the 4, the one that we're most familiar with is the force of gravity, the force discussed in example 3. Electromagnetism, or the electromagnetic interaction, accounts for all electrical and magnetic phenomena, and like gravity, is another interaction that we're familiar with from our everyday lives. Interestingly, examples 1, 2, and 4 are all examples of this interaction. In particular, the contact forces in 1 and 2 arise due to the atoms in the two bodies interacting with each other. These atomic interactions are fundamentally due to the electrical forces between the negative and positive charges that make up atoms. Do you remember that gecko at the beginning of the video? It definitely has a soft spot for electromagnetism, given that that's the interaction which is responsible for the incredible ability of these animals to stick to walls and ceilings. The 2 other fundamental forces involve interactions between subatomic particles. These are the strong nuclear force, which is responsible for holding a nucleus together, and the weak interaction, which is of vital importance when it comes to interactions between fundamental particles and is responsible for the radioactive process of beta decay. If you found this video useful, please like it, share it, subscribe to the Forest Learn channel if you haven't already, and leave a comment. I'd love to hear from you. Thank you for listening, and I hope to see you soon.